All right, Algebra 1A students. Welcome to part 2 of lesson 2.4, where we are solving equations with variables on both sides, and we're adding more steps to our equation solving today. Okay. In problem 3 in this example here, they're asking what is the solution of this crazy long equation with sets of parentheses on both sides. 2 times 5x minus 1 in parentheses equals 3 times x plus 11 in parentheses. Now, when we see parentheses with a number multiplied in the front, like this 2 right here, what we have to think of is the distributive property, where I go doink, doink, and I multiply the 2 that's in front by both pieces that are inside, right? So I do 2 times 5x, 2 times 5 gives me 10x, and then I also do 2 times a minus 1, which gives me a minus 2, because 2 times 1 is 2. So the left side of my equation now says 10x minus 2, okay? Still my equal sign in between here, and then the right-hand side, where I'm going to do exactly the same thing, the 3 to the x and the 3 to the 11, I multiply both of those, and I get 10x minus 2 is equal to, on the other side, well, 3 times x is just 3x. And then it's plus, well, what's 3 times 11? 3 times 11 is 33. So I end up with 10x minus 2 equals 3x plus 33. Now, this equation looks like what we were dealing with in our last video, where we have variables on both sides, so we have to move the 3x's over to be with the 10x's. I have to get rid of the 3x over here. I want to move this whole chunk. It's currently a positive 3x, so I'm going to subtract 3x from both sides. Right, I'm going to subtract 3x from both sides. So what I have then over here is 7x. It still has the minus 2 attached, and then it is equal to 33. Right? Now I have to get the x that's now only on this side isolated all by itself. I'll undo the minus 2 by adding 2. And I get 7x equals 35. And then to get the x isolated all by itself, I'll divide both sides by 7. Divide by 7. And I get that x is equal to 5. Okay, x is equal to 5. I've taken this crazy long equation with parentheses on both sides, and I've gotten it to the solution for x, the number for x that will make this equal on both sides. Okay. The first thing I did again was distributive property, multiply the 2 by both pieces that are inside the parentheses, both pieces in the parentheses. Okay. I'd like you to try one. Well, actually, let's go through this one together as well, because this one is slightly different only because the parentheses that I see here have a minus sign in front of the parentheses, but no number, right? It's 8 minus, and then right away there's parentheses with no number right in front of those parentheses. When we see a minus sign in front of parentheses, and there's no number in front, what we have to think of is a minus 1. Okay, it's minus 1 times all of these things. So what I do then is I take this minus 1 right here, the minus 1, and I distribute that to the 3 and the b. So when there's just a negative sign in front, put a 1 there by the parentheses and distribute the negative 1, multiply the negative 1 by both pieces in the parentheses. So now I think maybe you can do this. You can solve this and then move obviously all the b's to one side, whichever side you want, and all the numbers to the other side and solve for b. Pause the video, take a minute to look at this one, distribute, and then try to move the pieces over and solve. Okay, when I do that distributive property, I end up with 8 minus 3 minus 1b equals b minus 9. The first thing I notice right away, 8 minus 3, these two numbers right here can be combined. That's a 5. 5 minus b equals b minus 9. Okay. So now I need to add, or I need to move all the b's to one side. And because I want to keep my b's positive, whenever I can, I'm going to try to add b's to both sides. Plus b to both sides. Because that'll cancel out this side. A minus b and a plus b will go away. And then b plus b, well, I got 1 here and I got 1 here, so total I have 2b minus 9. And it's equal to 5. Now from here, hopefully we can solve without too much issue. Add 9 to both sides, divide by 2. We get that b is equal to 7. Okay, b is equal to 7. So it comes from, again, distributive property, combine these two numbers here, and then just move the variables to one side and move the numbers to the other and solve. Okay? If you have questions about that, make sure you ask me in class tomorrow. Before we end this video, however, we have to talk about something that could possibly go wrong while we are solving these equations with variables on both sides, okay? And what could go wrong is all of our variables could actually disappear. So let's look together at this example here where I have 10x plus 12 equals 2 times 5x plus 6 in parentheses. Again, this is just like up above where I see I have parentheses with a number in front, so I'm going to distribute that to both of the pieces inside where I multiply, multiply, multiply. 2 times 5x is going to give me 10x. 2 times the plus 6 gives me plus 12. 2 times 6 is 12. Okay? Now, my equation now says 10x plus 12 equals 10x plus 12, right? And now the next thing I need to do is get all of my variable pieces to one side. So I'm going to take this 10x over here, and I'm going to subtract it to get rid of it. I don't want it on this side anymore. I'd like all of my x's over here. Really doesn't matter which way you move them in this case, but I'm going to subtract 10x there as well. Now what we have to notice is that on this side as well, 10x minus 10x means all of my x's are gone, right? So my x's actually canceled on this side as well. So what's left over here? Just a 12. And what's left on the other side once we cancel out these 10x's? Well, there's just a 12 over there as well. So my equation now says 12 equals 12, right? So notice, all my variables disappeared. All variables disappeared. There are no more variables. The x's all went away. They all canceled out, okay? Which means once my variables all disappear, I have two options. Two options. It's going to be one of two options. It's either going to be no solution, or it's going to be infinite solutions, which means any number I put in for x would work just fine here. Okay? Any number I put in for x would work fine. So it's either going to be no solutions or infinite solutions when all of my variables disappear. Okay? All variables disappear, no solutions or infinite solutions. The way we decide is we look at what is left. Okay, we look at what's left. And what's left in this case? Well, it's 12 equals 12. We ask ourselves the question, is it true? Okay, is it true? Look at what's left. Is this true? Does 12 in fact equal 12? Well, the answer here is yes. So when it's yes, that leads us to our answer. When the answer is yes, then for this equation we would say infinite solutions. Okay, when the answer to that question, look at what's left, is it true? If the answer is yes, we say infinite solutions. If the answer happens to be no, like let's say it ended up being 12 equals 5. Is that true? Does 12 equal 5? No, definitely not. Right? Definitely does not. 12 does not equal 5. So we'd cancel that out. No. And if the answer is no, that also leads us to our answer. And the answer is no solutions. Okay? So when the answer is no to that question of is it true, then we say no solutions. Okay? So please make sure that this gets in your notes. I'm going to want to see this stuff in your notes. No means no solutions. Yes means infinite solutions. Has to go in your notes. So when all of your variables disappear, look at what is left and decide, is it true? If it's true, infinite solutions. If it's not, no solutions. Okay? So I'd like you to take a look at a couple here. Letter A and letter B. Solve each of these by distributing first and then moving all of your variables to one side. Your variables will all disappear, and I want you to decide, is it no solutions or all solutions? Once you have decided, come on back and I'll show you what we should get. In letter A, the answer here is most definitely infinite solutions, because we end up with, when we distribute and then subtract 12b from both sides, we get negative 6 equals negative 6. And negative 6 most definitely does equal negative 6. The answer is yes, so we say infinite solutions. Okay. Now in letter B, when we distribute the negative 1 and then minus 2x on both sides, the x's go away, and we're left with 7 equals negative 3. Does 7 equal negative 3? Most definitely not. The answer there is no, so we would say no solutions. Okay. So when all your variables disappear, those are your two options. If the variables don't disappear, we just solve it like normal. X equals this, A equals that, B equals this. But if the variables go away, you have two options. Infinite solutions, no solutions. Okay? If you have questions about any of this, solving with variables on both sides, what to do when all your variables disappear, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.